All right, so what I want to do next is go through just a couple of examples using mid-segments. This is the only idea in section 5.1. So to go through a couple of examples. So here's my triangle, or my triangles for this example. And I'm going to call this point, we're going to have D, O, E, N, F, and M. And I'm going to mark some segments here. So before I write the question that we're being asked, these sides of the smaller triangle, how are they related to the what are they? We know that these two pieces are the same. So what is point O for this segment? It's a bisector. It's the midpoint. How about segment N for this segment, since these two are the same? Also a bisector, also a midpoint. And that, since those two are the same, also a midpoint. So what kind of segments are these? They join two midpoints. Those are all mid-segments. So the small triangle is made of mid-segments. So a triangle has three mid-segments because we can join any pair of sides at their midpoints. So we have three mid-segments, so we get a little triangle inside. So what the question is here, now that we figured out what's going on, we want to know which segments are parallel. And we're just going to look at the segments, the sides of the big triangle and the sides of the small triangle there. So I'm going to say DE is parallel to, so we're looking at that side. Which segment on the small triangle is that going to be parallel to? MN. And how about DF? So we're looking at this one now. What's that one going to be parallel to? ON. Visually, it's pretty easy to see. So those two are parallel. And that finally, that just leaves us EF and OM. So those segments will be parallel. And we could do pieces also. We could say MOM is parallel to EN. That would be fine as well. So the mid-segment of a triangle is parallel to the opposite side, or the third side. Mid-segment joins two sides. It's parallel to the third side. All right, questions there? Okay, let's look at another example. This time we'll talk about lengths. And I'm going to say that this is G, H, and K. And the problem is going to tell us that G, H, and K are midpoints. I'll call this S, R, and T. So since G, H, and K are midpoints, what does that make these segments that make up the small triangle there? Well, if each of these is a midpoint, and we have a segment joining the two midpoints, what kind of segment is that? Mid-segment. Each of these is a midpoint. Got a segment joining those two midpoints. We have a mid-segment. So again, the small triangle is made of mid-segments. All right, and we know that RS is 28, GH is 20, and RH is 22. We want to know KH, ST, and GK. Well, let's start with KH. There is KH. So which side is KH parallel to? RS. So those two are related. Well, we know that RS is 28. So KH is 14, half as long. So KH is 14. All right, let's look at GH. GH is 20. What side is it related to? ST. Those two are parallel. Well, if GH is 20, how long does ST have to be? 40, twice as long. And then finally GK. There's GK. And we know that GK then has to be parallel to RT. But this tells us that RH is 22. Well, if RH is 22, how long is this whole segment RT? 44, because this is in the middle. So that's 22. This piece has to be 22 also. So how long does this one have to be? 22. Half as long as that whole thing. So the mid-segments are half as long as the opposite side, or the opposite side is twice as long as the mid-segment. All right, we're good there. So we always like to throw in a little bit of algebra here. So let's look at a problem that has to do with a little bit of algebra. All right, so before we write anything down, what kind of segment is that? That's a mid-segment. It's joining the midpoints of the sides of a triangle. The fact that each of these is the same, each of those is the same, tells us these are midpoints. So we know already that that is a mid-segment. And the problem tells us that the mid-segment is x plus 2, and this side of the triangle is 37. And we want to find x. So we can set up this equation in two different ways. What's one way we could set this up? The mid-segment is what compared to this? Half. So we could say 37 divided by 2 equals x plus 2. So we could solve the problem that way. 37 divided by 2 is 18.5. It's x plus 2. Subtract 2, and we get x equals 16.5. What's the other way we could set it up? The base of the triangle is how many times this one? Twice. So we could say 2 times that whole thing, x plus 2 equals 37. To do it this way, I would distribute first. So 2x plus 4 equals 37. Subtract 4, 2x equals 33. Divide by 2, and I get x equals 16.5. You get the same answer either way. All right, questions? Okay.